Let the sparks fly on this one today, literally. I got given this Technics receiver to look at and I made a mistake, and quite a costly one. I won't let the cat out of the bag just now, you'll need to watch this one to find out. The original fault was won't turn on. Well, it's more than that. The left channel has DC on the output, so let's check it out. Greetings, the Astro 30 here yet again, and today I've got a Technics SU-V85A stereo amplifier to look at today. The problem on this one is apparently it doesn't turn on, which is not really very helpful, but it's a Class AA, which I'm not 100% sure what they mean. So anyway, what I'm going to do is I'm going to plug this into the dim bulb and we're going to, well, verify what the fault is. Okay, I got it plugged into the dim bulb, so I'll turn the dim bulb on and then turn the unit on. Yeah, that's not good. There appears to be no life on the front panel whatsoever, and the dim bulb just seems to wash out the entire frame of the camera. So that is glowing at full brightness, so that's not a good start. So probable causes could be is, well, there's only really two that could be a problem, is the transformer itself may be shorted on one of the windings internally, which is possible, but it's not going to be definitive until we do some testing. Or the more likely is we have a shorted transistor on the output stage. So next thing I'm going to do is I'm going to take the top off and have a look inside to see what we're dealing with. Oh wow, huge transformer. And there's a look at the main PCB, which is mostly the power amplifier. There is a relay down here, which I'm assuming is some form of DC protection, possibly. And two large package transistors here. One's a 2SA130 and the other's a 2SC3280. These would be the emitter degeneration resistors, so I can measure on the center pins of each with respect to ground, just to make sure that we don't have any DC on the output. So that'll be the first thing I would do, is do that. There are two fuses here which are color coded, but both look to be fine. Monster power transformer, so if that is shorted, good luck finding another one. What I'll do is I'll fire up the multimeter and I will connect, I might use some crocodile clips actually, I'll connect my positives meter lead across each of these centers and we'll just see what's going on. Oh, hallelujah. Alright, so I got the multimeter connected to the, I think that's the left channel output's degeneration resistor stack. Okay, so I'll just give it some power. It's minus 467 millivolts, which is probably a bit high. So I'll just switch to the other channel. Turn him back on. And it's about the same. So it doesn't appear to be like, well, at first glance, any DC on the output. Let me just make sure that I've got the grounding correct here. Okay, so I've gone directly off of the negative speaker output just to make sure. And it is exactly the same, no change. So let's change the channels and try that again. Exactly the same, nothing has changed. So what does that mean? Well, at this stage, not much. Now, the dim bulb could be limiting the current so much because something is actually shorted. And so then we're getting that little DC offset because there's not much current coming out of the transformer because the voltage has been dropped. So the only thing I can do is actually just test each of these transistors because they're handily available to test and see if one of them is actually indeed shorted. So that's going to be my next test. Alright, so I'm ready to test these transistors. One's PNP, one's NPN. So for the PNP, which is the green one, that's going to be from left to right, base, collector, emitter. Or at least it should be. I'll soon find out. So it's got a negative base, so the negative probe goes on the base. So I'll put that there. That's a normal diode junction. That's also a normal diode junction. So I'll test the other one, but I'll let you look at the meter so you can see what I'm doing. And I'll turn the annoying beeper off as well. Okay, beeper is off. So we'll test that PNP again so you can see what I'm doing. So negative on the base. Normal diode drop on the collector. Normal diode drop on the emitter, which is slightly higher than the collector, which is normal. And if I reverse the connections, well, it looks like a higher diode, but it's only because of the stuff in the circuit that's connected to it. So that is a perfectly working transistor. Its counterpart, the NPN, has a positive on the base. If I can get a good connection, there we go. Lost it. Right, there we go. We've got a normal junction on the collector. Pretty normal on the emitter, although the collector looked higher. Yeah. Anyway, the next transistor on the other side, which is the PNP, so negative on the collector, base. Normal diode junction, normal diode junction on the emitter, and for its counterpart, the NPN, normal diode junction on the collector, normal diode junction on the emitter. So there doesn't appear to be a shorted output transistor, which is a good thing, because trying to find replacements of these power transistors online is a very dicey thing. Because there are a lot of these old, I don't even know who makes these anyway. There's no manufacturing details on it. Oh, it's got a T on it. Probably Toshiba or something like that. Most of the Toshiba, Sankyo and Sankan transistors and all those, Motorola especially, are all faked by China because the die is too small on the inside of the power transistor. They've basically taken a signal transistor die and put it on the inside of a larger package to make it sell as a hard to find rare transistor, only to find out that when you put it in, it blows up. Well, it either releases the magic smoke, or the internal diode junction fries and goes open, and then that's the end of that. So what does this tell us? Well, not much at this stage. It does tell us that the output stage, for all intents and purposes, is functioning, but we don't know how well it's functioning. And we do appear to have, I believe, 2 op amps, either power amplifier side here. So they may be using that as an input stage. I don't know. I'd have to look at the service manual for this to see basically how the thing is wired. But what this doesn't answer is, why is there so much current being drawn on the dim bulb? And there is no indication on the front panel anywhere as to whether the thing is on or off. There's nothing else I can actually do here to determine if there's a short, except disconnect the wiring from the board and then test again. I'm going to turn that off so the dim bulb's not constantly glowing. Or I could unsolder this PCB from the transformer so that's not actually connected to the board, because there's this smaller wire here which has three connectors on it, which probably power the low powered side, like the preamp. Oh, hallelujah. So yeah, I think my first course of action is I'll just disconnect this board away from the transformer so there's nothing else connected to it except the primary. wiring and see if we get a different result on the dim bulb. Well, I've got the thing loose. Alright, the board is now disconnected from the transformer, so I'll prop him out of the way somewhere where it won't come into contact with anything. So with the secondaries disconnected from the transformer, let's see if we get a different result. Indeed we do, look at that. So something on the main PCB here is drawing too much current. But what is that? So measuring in continuity mode across these two wires, big wires. There is no continuity, so there's no short. So I'll just do these smaller ones. Nothing, nothing, and nothing. So there's no short circuits on this PCB. The input to the thing is not shorted. There is a bridge rectifier down here. Now, it's not marked on the PCB which is positive and which is negative, but I'm going to assume it's that way around because the flat pit is on this side and we've got infinite ohms there, so it's not shorted on the secondary side of, well, the DC side of the rectifier. So that doesn't really tell us much either. So this is pretty perplexing as to what is going on. There is actually some LEDs on the front panel here which light up to indicate which input channel you're on. So they should be glowing, but they are not. And of course the dim bulb could be limiting the current too much, so that it is not actually allowed to fully power up the circuit. I'm assuming this has been plugged into the wall already and tested before bringing it to me. So I could be just chasing a red herring here and thinking there's a short circuit when there's not. And, well, there's no short circuit across the power supply. As far as I know, well, I can actually do it at the collectors of these output transistors. Because one should be positive, one should be negative. And again, there is no direct short there, and on the other side it's completely open as well, so there's no short circuit across the high side current supply rails. So the other thing I could do is I could put the secondary board back onto the transformer and I could actually power it unencumbered, like bypass the dim bulb, because that's not really telling me much right now. So that's going to be my next step, and I hope I do not blow a circuit breaker, because if I do, well, I don't have circuit breakers. If I blow a fuse, I'm going to be annoyed. And besides which, there's a 6.3 amp fuse here, which would come directly in across the input line, so across the live. So if there was anything wrong with the transformer, it would take out that fuse first before, you know, blowing the one in the house. I reckon what they're doing is they're using a 3.15 amp, which is half of, well, 6.3. for 120 volt and 6.3 for 240 volt, or the other way around. So yeah, so it's got fuse protection, so it's not like it's going to blow up the house fuse. So I'll reconnect this and turn it on and run directly and see if we actually get any life on the front panel. Alright, dim bulb's removed, and it's got a very nasty stiff line cord on it, which I don't like. Move the shapes out of the way. So here we go. Well, it turns on. We do have life on the old front panel. And, well, the functions on the front appear to do things, but the relay doesn't engage. Alright, so I'm going to do that output transistor DC voltage check again. Alright, well, there's minus 57 volts there, which is not right. So let's check the other channel. That one appears to be operating as it should normally with only about 4 millivolts. So we now know the left-hand channel, this one here, has DC on the output, and the output transistors are not shorted. So why is it so? Said old Julius Sundermiller, why is it so? Does anyone else remember that? Well, I don't, because I'm too young, but I had a friend that used to mention him all the time when he was trying to figure out a problem. And then I eventually looked him up, and he was like this television presenter about science and physics and stuff like that. It was fun. But anyway, that's getting off track. We've got minus 57 point or some whatever volts on the left-hand channel. So it's appearing that we've got the actual negative rail there. Now, question is as to why. Now that'd be the reason why the relay isn't turning on, because that'd be a DC protect relay, I'm going to assume. And that transformer is humming away, and quite annoyingly actually. So I'll turn that off. And interestingly, the voltage on the multimeter instantly disappears. So we've probably most likely got an open component somewhere. So what I'm going to do is I'm going to look at the schematic now, if I can find one for this, and just see how the power amp stages are actually configured, so we've got a better understanding of what's going on with the circuit here and where I can go to test next. Right, after downloading the service manual off of manuals.lib, you can get off Hi-Fi Engine just as easily, but that's the first link I found. I found the schematic for it, and we're looking at the left channel output stage here. These are the two output transistors, and it is a emitter follower, so that's handy. And there is voltage measurements here at each base saying 0 volt, but they are going through 2.2 ohm base current limiting resistors. So in the past, if one of these is open, well then one transistor is going to be driven hard on, producing the DC offset on the output. However, I've got my multimeter hooked up to the chassis, so what I need to do is I want to measure the voltage at each of these bases here. So I'll turn the unit on, which it is, and I'll go for this transistor's base. We've got, interestingly, negative 57 volts on the base of the PMP, and on the MPN we've got minus 55 volts, which doesn't seem right, so I'll check it with the known working channel. As far as I know, it's working. Yeah, we should have mostly bugger all, which we do, and with the MPN, bugger all. About 0.6 of a volt, which is nothing. So, well, it's enough to turn the transistor on. So, we now know there's an issue at the bases of these transistors. So, what I should probably do is measure the two resistors that go across the bases. Measure these two resistors here and here, and make sure that they're not open. So, that's R529 and R531. That's that resistor down there and that one over there. So those two there. Well, it looks like I might have to do a little bit further digging because both those resistors aren't open. So they're measuring around about 2.27 ohms. Which is good because I don't have any 2.2 ohm resistors of that style. So, yeah, the next thing I'm going to have to do is just really study the schematic and start measuring voltages around the place and see what's off. Okay, so about half an hour to 45 minutes later, I've done some voltage measurements and some basic component tests like resistors and diodes and transistors. I've checked all around the voltage amplifier circuitry and the current amplifier circuitry, and like for transistors that are shorted or the such, there doesn't appear to be anything shorted. I was getting a 0.03 volt between a base and collector, I believe it was, on a couple of the transistors here, or no, it was emitter. But I compared it to the other side, they're both the same, so that's not the issue either. Now I've been going through looking for voltages as well on the power amplifier, or current drive amp, whatever they want to call it, and I measured the voltages at pin 8 and pin 4 with respect to ground on this op amp, and both have minus 57 minus plus minus a volt, a different voltage on both pins with respect to ground. However, with respect to each other, 4 and 8 have like around about 7, 8 volts, where it should be more closer to 15, because 8 gets positive 7.5 volt off of the series pass regulator here, and pin 4 gets minus 7.5 volt off of this series pass regulator down here. That's not really helpful, and this resistor up here, 501, which is 470 ohm, that appears to be our input path, and there's minus 57 volt there too. So I can't find any issue with the components. These Xeno diodes here and here, they appear to be functioning correctly. It's like 2 volt in the reverse direction, and 0.6 of a volt in the normal direction, so that's not an issue. I can find no open components. These 2 diodes here and here are fine. All the resistors here in this circuitry for the VBE multiplier, they're fine. Even the variable resistor, which is a 500 ohm, is between 2 pins which are not joined physically together. I'm getting about 280 ohms, so well, that's obviously functioning. It's not short circuit or anything. So I'm really at a loss as to why now we have minus 57 volts on pins 8 and pin 4 with respect to ground, and only 8 volt with respect to each other. I don't know. So the only thing left to do now is probably to remove the main PCB out of the unit. I can't because all the wires are hardwired, but pull it out enough to turn the board over to inspect the solder joints on the bottom, because there's no removable bottom panel. Thank you, Japan, for removing that option. And just check solder joints and everything around the circuit, just to make sure that we haven't got something that's open or Alright, so I've taken the PCB out as best as I can. The wires are a bit short, so it's awkward to work on and awkward to film. I removed the transistors off of the heatsink rather than remove the heatsink with it, because there's just too much weight on those output transistors, so it's just as easy to unscrew them from the heatsink. Now, from visual inspection between the 2 channels, around this voltage amplifier section here, these 3 transistors which are mounted to the heatsink, well, 2 are mounted to the heatsink, one's actually just like a VBE multiplier, I guess. The joints on the 2 larger devices do look fairly suspect, like the collectors don't even look like they're joined. These up here aren't soldered, which is the output transistors, and they look like they're not soldered. However, they don't connect to anything. They are connected on the other side elsewhere. So that's not really an issue. But comparing the other voltage amplifier transistors over here, which is the apparently working channel, I'm going to say, they look fine. And there's a few other awful looking joints in this output section as well, so I might go ahead and retouch those joints up and see if we get anything different in results. So I'll bring you in closer to have a look. I don't know if you can see it on camera, but the joints don't look that great there, and there's a transistor up there which doesn't look correctly soldered either. And there's a few other dicey looking joints, so I'll get to soldering them or reflowing them and see if we get a different result. Alright, with the PCB back in, I'm going to plug the unit in and see if I've made a difference. No, I just blew a fuse. Ooh, lovely. Well, if we didn't have a short output stage before, we do now. Both these output transistors are now stuffed. I had inadvertently had a solder bridge between 2 of these pins on this transistor here, so Yeah, that was my fault. So I think I've now destroyed the output stage because they're dead short circuit now, so that's not going to work. So I'm going to have to remove those transistors out of circuit and put a new fuse in and put it on the dim bulb this time. And yeah, see if we get something different. Alright, the transistors are removed, and it turns out the PNP which is there is not shorted, the NPN is. So I've destroyed the NPN transistor. At least it's better than destroying both. I've popped a new 3 amp slow blow fuse in place of the one I just blew. And it's going through the dim bulb this time, which I wasn't doing before, which I should have done. Still glowing brightly as a mother. So, okay. Alright, I got it hooked up directly to the power point. All I can do is just blow the new fuse I put in. And if it does, that's where I'm stopping. Whoa. Okay. There is something definitely wrong with this amplifier. I got a shorter driver transistor on that side too. Now I've got it plugged into the dim bulb. It's actually glowing pretty dimly, so it should be safe now to plug it directly into the wall, I hope. So here we go. Ah, lovely. No explosion this time. Still no relay action. Let's try. Okay, I've got it into a working state and I'm probably going to leave it there, but I've still got no relay. So I might hook up the multimeter across the output of that channel, even though the transistors aren't in, and see if we still got that DC offset. Okay, got it connected across the resistor output. Yeah, there's DC there. Okay. Right, there's not much more I can do with this amplifier except order a new output transistor and try again. And a driver. At this stage it's looking like it's not going to be very repairable. This is so annoying, but at least I captured you know, the sparks and shit on camera, which was cool. So yeah, just let that be a lesson to you that you really need to put things through a dim bulb port first to make sure they're not shorted. There apparently appears to be no short circuit now, so yeah, that was epic. Anyway, I'm going to order a couple of transistors, put them in and hope they don't blow up. I didn't really want to blow up the output stage because yeah, finding original transistors of these is going to be awkward. However, yeah, that's just what happens. So I just remember to take my 3 amp fuse back out before I put the thing away. And I have to get the correct fuse anyway, but mistakes happen. This is what happens, so yeah. Alright, well anyway, I'll order them up, so I don't know how long that's going to be. I mean, that may not fix the original problem. We may still be back to square one there, so that'll be even further diagnostics. But hopefully we'll have, you know, no short circuits and a working output stage. It was all because I accidentally shorted the first driver transistor between the collector and the base. I think it was that way around. It might have been the emitter and the collector, whichever one. And then just blew the arsehole off the amplifier. So yeah, well, alright. So anyway, this is the Astro 30 saying, I hope you enjoyed this video, even though I didn't really do anything, but yeah. If you did, please remember to go down below, like, comment and subscribe. And yeah, this is the Astro 30 saying, see ya. I'll see you in the next one. Thanks for watching.